What if your AI agents could fix each other's failures without you waking up at 3 a.m.? This week I shipped a full multi-agent orchestration layer. And at one point, two of my agents were literally fighting over the same state object. It was chaos. But by the end of the week, the system was dynamically reassigning failed tasks on its own. My CCD was deploying in under 45 seconds. And 7 trading strategies ran overnight across 3 markets with 0 position errors. Let me break down exactly how we got there. Here's the ugly truth nobody talks about when you scale beyond one AI agent. State management becomes your biggest enemy. My Discord bot team had 2 agents that were both reading and writing to the same state object directly. No locking, no registry, just pure chaos. One agent would update memory. The other would overwrite it a millisecond later. On top of that, an API key started expiring midday and almost killed my trading bot's refresh window. And my video encoding job? Running at 20 frames per minute instead of 60. Because I hit a GPU queue bottleneck I didn't see coming. The core lesson this week was brutal but simple. Multiple agents cannot share state objects directly. You need a central registry that every agent reads from and writes to through a controlled interface. Think of it like a database, not a shared variable. Once I wired that in, the conflict disappeared immediately. For the API key problem, I added proactive expiry monitoring with a buffer window so rotations happen before they become emergencies. And for encoding, I rescheduled those GPU-heavy jobs to off-peak hours. 3 separate problems, but one common theme. You have to design for failure before it happens. The part that genuinely amazed me this week. Once the state registry was in place, the orchestration logic just clicked. My task routing agent can now detect when a downstream agent fails and dynamically reassign that task to a backup agent in real time. No human in the loop. The error recovery loop in my content pipeline actually handled a failed encoding retry completely on its own. I only found out because I checked the logs the next morning. This is what an actual AI agent system looks like in production. Not a chatbot. A system that adapts. If you want to go deeper, check out OpenSquilla on GitHub. It's trending right now for token-efficient agent design with a similar philosophy. Let me give you the actual scorecard. Full multi-agent orchestration layer. Shipped. 7 trading strategies across 3 markets running overnight. 0 position errors. Vercel deployment pipeline hitting under 45 seconds consistently. YouTube content pipeline handling rate limits automatically with double buffered upload requests. After I learned the hard way that YouTube's API throttles way harder than their docs admit. Paper trading even hit a 4-candle green streak. Which reminded me exactly why we're building this. The system isn't perfect. I still need tighter stop-loss logic. But the foundation is solid. One more thing from the news this week. A police officer used AI to fabricate evidence. That's a reminder that how we build these systems and the guardrails we put in them really matters. If you're building AI agent systems, or you want to start, this channel is where I document everything raw and unfiltered. The wins, the 3 a.m. debugging sessions, the lessons I wish I'd known before. This week's big takeaway. State management is the invisible wall that stops most multi-agent systems from scaling. Design your registry first, before you build anything else. If this video helped you, hit subscribe. I drop a new builder update every single week. And drop a comment below telling me, are you building with multiple agents yet? Or still on your first one? I read every reply. Let's build.